Okay, today's lesson is on finding the distance between 2 points. And we're going to continue what we were doing last week on Thursday when we learned about the Pythagorean theorem. Remember that the Pythagorean theorem is a squared plus b squared equals c squared. So when we find the distance between 2 points, we want to know between 2 points, how long would a straight line be? So what we're looking at on example 1, I gave you a couple of graphs and we have to determine the distance between those 2 points. Now, example 1, the first one, we'll call this one A. If you look at this particular graph, notice that the line is a straight line, horizontal, and it's not slanted at all. And so what I'm able to do anytime I have a horizontal or a vertical line that is straight, not slanted at all, then I'm able to count blocks and I can tell you how long that line is. So from the point -4, 4 to the point 3, 4, if I count blocks, I would count 1, 2, 3, 4, 5, 6, 7. So this particular line is 7 units long, which means the distance between the 2 points is also 7 units. So that would be the answer to A. So when you get one like that, those are pretty easy. There's not much to them other than just counting the blocks. Now when you look at the second picture, we'll call this one example 1B. The second picture, you have a line but it's slanted. We can't count blocks when a line is slanted. It actually goes through blocks, and so it's harder to count. So what we have to do is have a way to determine how long that line is. Now, there is a formula called the distance formula, and you will have that to use as you get a little bit older. But for the 8th grade year, what I want us to use, and what I think is actually the easiest method, is to use the Pythagorean theorem. And so I'm going to show you how to do that. Pythagorean theorem, remember from last week, Pythagorean theorem only works on right triangles. So in order for me to make this work and find the distance between those 2 points, in order to find out how long that slanted line is, I have to create a right triangle. So what I'm going to do is I am going to use this slanted line as my side C. And I'm going to create the other 2 sides. Now I can either go from the top point, I can go down and left, or I could go from the bottom point and go right and up, or I could even go up and right, and it wouldn't matter, I'd get the same answer as long as I use this line to be my C and I make a right triangle. Remember, it has to be a right triangle. So I'm going to go straight down and then straight across. And that does make a right angle. So what that does make is a right triangle where I have the legs A and B that I've drawn, and I'm trying to determine the side length of C. So using Pythagorean theorem, I'm going to write that down, a squared plus b squared equals c squared. And I'm going to plug in what I know, A and B. I don't know C because that's what I'm trying to find. Now A and B, I don't have them labeled, but I can easily find those by counting the blocks. 1, 2, 3, 4, 5. That side length is 5. Across the bottom, 1, 2, 3, 4. So that side length is 4. So I'm going to use 4 for A, 5 for B. So 4 squared plus 5 squared equals c squared. Then I'm going to square the numbers. Now you have a problem just like last Thursday. I'm going to square 4 and get 16. I'm going to square 5 and get 25. And bring down my plus sign and equal c squared. Now to add 16 plus 25, 16 plus 25 would be 41 equals c squared. And don't forget, the final step always on Pythagorean theorem is to take the square root of both sides, which will leave you c. And then if you take the square root of 41, and again you're going to need to use your calculator for that because we have to round it to the nearest tenth. So rounding to the nearest tenth, I would say that's about 6.4. And we don't know if it's centimeters or meters, so we just call it units when we don't know what it is. And so that is the answer to B part. So all you have to do is take your side, your line, it's slanted, that's going to be C. Draw you a right triangle and count the length of the sides of those legs, and then plug it into Pythagorean theorem. So that should be pretty easy. All right, example 2. Same thing, but sometimes instead of giving you a picture, sometimes they just give you the 2 ordered pairs, and you have to create your own picture. So I'm going to start by graphing those 2 ordered pairs. So I'm going to graph 1, 2, and then I'm going to graph -2, 5. And I want to know the distance between those 2 points. Well, when I graph that, that's a slanted line, so that's going to be my C. And then I am going to draw my line from the top point to the right and then down, and that's going to make a right triangle. So if I count the side lengths of my blue legs, I have 3 on the right, and on the top I also have 3. So I have a right triangle where A and B are the same thing, they're both 3. And so I'm just going to use my formula, and I'm going to plug in what I have. So I have 3 squared plus 3 squared equals C squared. So 3 squared is 9, so 9 plus 9 equals C squared. That would be 18. If I square root both sides, I get C equals the square root of 18. And that is rounded to the nearest tenth, 4.2 units. And that is all you do for today's lesson. You just are trying to find the distance between 2 points, which is how long a line segment is. And you do that by making a right triangle and using Pythagorean theorem. And that is all you do. So I'm going to let you try some on your worksheet. When you do your assignment today, the first worksheet is what I want everybody to do to practice. When you finish that, there's an extra practice worksheet. I'm going to let you decide if you need to do that or not. If you do, go ahead and do it. If you're not, you can work on bell work for the remainder of the time.